So to start today, we're going to turn to page 40 and do this warm-up problem. Temperature over the year is periodic. So let's define periodic. This is any data that repeats. So it would look like a sine or cosine when you make a graph. The highest average monthly Fahrenheit temperature in Atlanta is 78.5 degrees in July. The lowest temperature is in January. Write a sine and a cosine function. Hint, plot the points to start. All right, so let's make a graph. The high is 78.5. The low is 43.5. Month 6 is July. January is month 0. So if it's 6 months to go from low to high, it's going to be 6 months to get back to the low. That's going to be 12. Connect the dots in a nice smooth wave. And there's our sine or cosine graph to write an equation for. So pause the video here, find the amplitude, the period, the midline, any horizontal translation. Okay, so for amplitude, we've got maximum minus minimum divided by 2. For the midline, we have maximum y value plus minimum y value divided by 2. The period, I'm going to go from minimum to minimum, that's 12. So the b value in our equation is 2 pi over 12, which reduces. Okay, so now that you've checked your values, write a sine and a cosine graph. Equation for the graph. I will start with cosine. Actually, let me set up, I'm just going to set both of them up. Okay, so for cosine, I want to look for a maximum. So that's shifted to the right 6. Or I actually could have used the reflection and had no horizontal translation. So let me write that out. So that's the reflection starting at 0. And then for sine, that's where the graph crosses the midline and goes towards the maximum. So this is going to be halfway here. So that's to the right 3. All right, so today we are going to focus on defining and graphing the tangent function and key features of that graph. So to start on page 41, recall that tangent is the opposite side over the adjacent side. So if we have angle A here, we've got opposite and adjacent. So let's revise this definition to be any angle of rotation on a coordinate plane in either radians or degrees. This is over x, up y. Tangent theta is y over x, which is the opposite over the adjacent. Does our revised definition of y over x change if the angle of rotation is in a unit circle, meaning the radius is 1? Is the length of the radius going to change our tangent definition? No, because r is not part of the tangent definition, or you could say ratio, which is the fraction. So we've observed that on the unit circle, the absolute value of sine and cosine can be represented by the length of a line segment. So unit circle, again, meaning the radius is 1. And depending on your quadrant, sine, regardless of the quadrant, sine was y over r, cosine is x over r. Then depending on the quadrant, sometimes that fraction was negative. Indicate on the following diagram which segment would represent the length of sine, which would represent the length of cosine, so sine would be BC over AB, or y over r. Cosine would be AC over AB, which is x over r. But if r is 1, that means that sine is the y and cosine is the x. So if we have tangent is y over x, well, I can replace y with sine theta, and I can replace x with cosine theta. So another way to define tangent of an angle is sine of that angle divided by cosine of that angle. This is called a quotient identity. It's a fraction. So tangent theta equals sine theta over cosine theta. And we're going to use that on the next page to develop our graph of the tangent function. Complete the table below from the unit circle. So that's when we had our circle centered on the origin. Let me see if I can draw that any better. Ooh, that's pretty good. So if the radius is 1, this point here is over 1 up 0. This point is over 0 up 1. Out here is negative 1, 0, 0, negative 1. Let's put our radians, because I notice we have radians, so let's put our radians on the quadrantals. All right, so we're going to start with sine theta. Let's start with these positives. At 0 pi, sine is y, 0 over r. Pi over 4 is not here. We'll get to that in a minute. Pi over 2, y over r. Pi, 3 pi over 2. All right, well, let's go backwards to these negative angles. So negative pi over 2 is a sine value of negative 1. Negative pi, negative 3 pi over 2, and negative 2 pi. Let's do the cosine of the quadrantals, and then we'll pull out our calculators to get these pi over 4 angles. So cosine's the x coordinate. So let's start again at 0. Cosine x, 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 and then x. All right, let's go backwards. Let's go negative. Go clockwise. Okay, so now let's pull out our calculators and do the pi over 4s. I'm going to check my mode. I have to be in radian mode. So sine and cosine of pi over 4 are 0.707. And then based on the symmetries of the circle, we know that any of these pi over 4s with that reference angle will also be the same value. We could type it just to show. That negative just meaning going clockwise. So clockwise down here to quadrant 4, the sine value is negative because that's the y coordinate. Cosine, take a minute and think, is cosine in the fourth quadrant going to be a positive 0.707 or negative? Positive, because we're to the right of the origin and the x coordinate to the right is positive. So we've got negative 0.707, positive 0.707. 3 pi over 4 will put us, oh, sorry, negative 3 pi over 4 puts us over here in quadrant 3. So they're both a negative y and a negative x. And now we filled in our sine and cosine values. So we're going to use that to find our tangent function values. We just on the last page defined tangent to be sine of theta divided by cosine of theta. So using our table up here, and I'm just going to go, I'll just go left to right. Sine of theta divided by cosine of theta. So what's 0 divided by 1? 0. Sine of theta divided by cosine theta. So 1 divided by 0, that's undefined. Can't divide by 0. 0 divided by negative 1. Now we've got negative 0.707 divided by negative 0.707. What is any value divided by itself? 1. And negative divided by negative is positive. Okay, so pause the video. You keep going. Fill in the rest of these tangent values. So we're going to do sine over cosine, sine over cosine. So now let's use these tangent values and angles to make our graph. Let me zoom out a little. Maybe I can fit it all. There we go. Any place that is undefined is a vertical asymptote. So we're going to graph a dashed line at any undefined values. So we've got negative 3 pi over 2, negative pi over 2, positive pi over 2, 3 pi over 2. Okay, so we've got these asymptotes repeating. Now let's plot the points. Negative 2 pi is 0. Negative pi is 0. Negative 3 pi over 4, that's going to be this little slash. So I noticed that this is pi over 2, so this must be negative pi over 4. 2 pi over 4, so this would be 3 pi over 4. I'm going to go to positive 1. And now at negative pi over 4, we're at negative 1. 0, 0. Pi over 4, positive 1. And so thankfully here around the origin, we have these 3 points to be able to connect our points to make our graph. At 0, 0, this is going to be an inflection point. We did that way back in our polynomial unit where the curvature changes. And that way we're going to approach our asymptotes. So I'm going to curve this piece down and curve this piece up. And then tangent, just like sine and cosine, are periodic. It repeats itself. The pattern repeats. So I can see here, this is going to approach the asymptote up. And then on this side, it'll approach the asymptote down. So let's fill in all the periods of tangent, approaching those asymptotes. And there is our beautiful tangent graph. All right, let's fill in our properties. The period is how often the tangent pattern repeats itself. So from here to here is the pattern that keeps getting repeated. So how far is it? What is the distance from negative pi over 2 to positive pi over 2? We can think this is a half plus another half, which makes a whole pi. So half pi plus half pi. Amplitude is half the total height. But because our curves continue up and down forever, this one has a range, which is not here, so I'll add it. The range of tangent is all real numbers, so there is no amplitude. Asymptotes repeat every period. So I can see we have all these repeating asymptotes. So they are vertical lines. We've got x equals. And I'm going to pick positive pi over 2 to start. So pi over 2 plus, and then how often does the asymptote repeat? What's this period in between? It's pi. And our asymptotes repeat every multiple of pi in the negative to the left and positive to the right. So we're going to say plus pi k, where k is an integer. So plus 1 pi plus 2 pi would get me out here. Minus 1 pi, minus 2 pi, minus 3 pi. We're going to do the same thing for the x-intercepts. Let's pick an x-intercept to start at. Let's do 0. And the x-intercepts repeat every pi units. So we're going to say every pi k, where k is an integer. And then for symmetry, is the tangent graph even, odd, or neither? It is odd symmetry because we have that rotational symmetry about the origin. If you turn your paper upside down, this graph would look exactly the same, that rotational symmetry about the origin. So your homework now is page 43 and 44. You're going to make some graphs and review domain and range and transformations.